Okay, Billy and Sean both completed a survey. They collected leaves from a number of trees and decided to measure them. So they agreed on the following decisions. Okay, so that the length, they'd measure the length, yeah, and it wouldn't include the stem. Okay, so the length of the leaf is all of the leaf part apart from the stem, and then they'd measure the width as well, okay, and the width would be the wider section. So they come to an agreement on this, okay, they come to an agreement on this, so they know exactly how to measure, how to identify the leaf. Okay, they know what characteristics there are with regards to that leaf in terms of how it's represented, because they're measuring the length, not including the stem, and then the width at the widest part. So part A then simply says, and why have they both agreed on these decisions about measuring leaves? Well, the main thing is that they're consistent, yeah? They will be measuring, you can say that, they will be measuring consistently. Okay. And what I mean by consistently, doing it the same way all the time, essentially. Okay, doing it the same way, right? So when they say about measuring the width of the leaf, they know they've got to measure the widest part, as it says, at the widest section of the leaf. They know they've got to do it there, not at the top where it's not so wide. Okay, they know they've got to go to the widest part. So they'll be measuring consistently. They're doing the same thing, same way for every leaf, and then doing it this way will allow you to compare fairly. Okay, so doing it this way allows fair comparison. Okay, we are able to compare the leaves properly because we know the lengths will be measured effectively, not including the stem, and we know the width is at the widest part. Okay, so Billy measured, part B then, the length and width of each leaf he had collected, and Sean did the same with his leaves. They displayed the lengths and widths of their own leaves on a separate scatter diagram. So here's Billy's here, and so you can see here they're quite scattered, aren't they, with Billy's, and then Sean's, there's a very nice pattern to it, okay? Okay, we can see here there's a trend to it, isn't there? Whereas with Billy's, it's scattered, they're all over the place, okay? Sean, there's this definite trend. So it says then, who found the longest leaf and write down the length of this leaf? Okay, well all you've got to do is look at compare the two scatter diagrams. You can see here Sean's, his longest leaf is over 10 centimeters. There's 10 point something, I'm not sure what, we'll have a look now. But when you look at Billy's, okay, his longest leaf is only 10 centimeters, yeah? Okay, 10 centimeters at most. So clearly Sean had the longest leaf. So we can say that, we can write down Sean, okay? And then to make sure we get that mark, then we need to write down the length of this leaf for Sean. So there, that measure there, 10 point something, isn't it? Well, if we don't know what the scale is, best way with a scale I always find is go halfway, go in the middle to start with. So let's go in the middle here, because I know that's 8 and that's 10, and 9 is going to go in the middle, isn't it? Okay, that's good. So you know where what the center is, and then we can easily decide. Then we can easily see. Look, between 9 and 10, well, that represents a gap of 1, doesn't it? How many squares are there? How many little squares are there? Well, there are 5 little squares, aren't there? 5 little squares. So we want to divide this gap of 1 by 5, right? And this is a calculator paper, so you could even, if you're not sure what that is, let's do 1 whole. From 9 to 10 is 1 whole. Divide that by 5, and you get 1/5, obviously, that's what that is. But press the SD button, 0.2, yeah? I mean, we should know that, but if we don't, calculator paper, you can check on it. So that means is that gap there of 1, okay, because there's 5 squares, the 1 has been divided into 5 squares. Each little square is representing 0.2, okay? So you can see here, with the length here, well, there's 2 squares up. So that means we're going to be going from 10, 1 square will be 10.2, 2 squares will be 10.4, okay? So that will be Sean's length of his leaf there. So then the next part then, it says, one of the 2 boys collected leaves from a variety of trees. Who was this, Billy or Sean? Give a reason for your answer. Well, I would certainly say that Billy is the one that collected from a variety of trees. Okay, you can look at Sean, because there's a pattern there, trend. You would be thinking then they probably come from the same tree, because the leaves are all sort of related to each other in that sense, because they come from the same tree. They've grown from the same roots, so to speak. There's going to be sort of a relationship there between the lengths and widths, whereas here it could be from random, all different types of trees, different makes, so then there's no pattern. So we can say that, right? We'll say Billy, okay, because with Sean's diagram, there is an obvious, and in this case it's positive, we could say, it could be an obvious positive correlation, okay, which means Sean's leaves are likely to come from the same tree. You know, in more detail the better. And you know, you could say, look, they will have the same characteristics, won't they? Or they will have, not the same, it's similar characteristics, which you can clearly identify from Sean's sort of data here, whereas with Billy's it's all over the place. So there's probably different tree types he's sampled. Okay, so draw by eye the line of best fit on Sean's scatter diagram. So with the line of best fit, it's got to follow this trend, okay? It does not go through the origin, okay? Sometimes you'll find the scatter diagram, the line of best fit will go through the origin, but in this case it clearly won't. What you need to do is make sure you've got a similar amount of points either side of that line. You don't want to do it like this though, okay? You don't want a line like that. You want to have a line that's going in the same direction, okay? The same trend of those points. And we've got a similar amount of points either side there, haven't we? Okay? Right? Don't worry about getting it perfect spot on, but as accurate as you can, right? Okay, so we've got, what have we got? 1, 2, 3, 4, 5 points that side, maybe 6, maybe 1 or 2 more, let's say, so we shifted a little bit, but I think that's okay there, okay? I'm happy with that there. All right, it is by eye, yours will be slightly different to mine, but as long as it looks similar to this, and when you draw your line of best fit then, it's got to go through the whole graph page, right? The whole graph page, and you can see roughly the same amount of points either side, okay, in a straight line. So said then, Sean realizes he has one more leaf that he's not included on the scatter diagram. The leaf is damaged, okay, so you can't measure its width, but the length is 8.5. Length is 8.5. So can we use this to help us? Well, of course we can, because if the length is 8.5, what you can do is go to 8.5, which is around here, right? Draw a line across, see where it hits your line of best fit, and then you can read down, see what it is. So if we read down, we can see then, we can see what it exactly going to be there, okay, the width of it. So it's going to be, well, I think we've got 7 there, that's going to be 7.2, that's going to be 7.4, so it's going to be 7.5, it's right in the middle, isn't it? 7.5, it's in the middle of 7, 6, and it's in the middle, sorry, of 7 and 8, so 7.5 centimeters for our width.